Students, this is the Unit 6 review on proofs. All of Unit 6 was about proving triangles that are congruent and proving other things about triangles, and I am going to walk you through a couple of these different types of proofs. Learning target for today, but we are going to be talking about two triangles that are trying to be proved congruent. We're going to be looking at overlapping triangles and sort of separating them out, and we're also going to be looking at triangles in coordinate proofs. Let's get started. Right, this is the first proof that is on your review. It tells you that C is the midpoint of BD, AB is perpendicular to BD, and BD is perpendicular to DE. So one thing that you should start doing right away before you even write out givens or anything like that is mark the diagram. So here's what the diagram marks should look like. You know that C is the midpoint of BD. That means it splits the line segment into two congruent parts. So here's from B to D. CD and BC are now congruent to each other because they're cut in half by a midpoint. So these statements A, B, and BD are perpendicular. BD and DE are perpendicular. Remember that perpendicular lines form right angles, so I'm able to see that in between line BD and line AB, where they intersect, that's going to be a right angle. And then BD and DE, here's BD, the horizontal line, and here's DE, the vertical line. There's your right angle right there. And there's one other thing that you are able to figure out, not from the givens, but from the way that the diagram is structured. It looks like these two angles, angle BCA and angle DCE, are joined at the vertex, and they're opposites of each other. They don't share a leg. And they're formed by two intersecting lines. You know what that sounds like to me? Like they're vertical angles, which means that they're congruent. Okay, now just looking at the diagram, I have some sort of idea as to what I'm going to use to prove that these two triangles are congruent. That's the thing I have to prove. So to prove that triangle ABC is congruent to triangle EDC, I can see that I have an angle here, a side here, and an angle here. In other words, a side in between these two angles. Since that side is included between the two angles, we say that this is ASA postulate. Understand the diagram, let's fill out the reasons. First, it says that C is the midpoint of BD, AB is perpendicular to BD, and BD is perpendicular to DE. We know all of these pieces of information because they are given to us. Next, it says that BC is congruent to CD. We know that BC and CD are congruent because this midpoint fact was given to us, because a midpoint splits a line segment into two congruent parts. So instead of saying a midpoint splits a line segment into two congruent parts, I'm just going to call it the definition of midpoint. Next, I'm looking at angle BCA and angle ECD. Those are the angles that share the vertex C. This angle and this angle are congruent because, as we said, vertical angles are congruent. I'm, again, just going to use definition of vertical angles. Next, I know that angle ABC and angle EDC are right angles. The only reason I knew that these two angles are right angles was because in the givens, I was told that the two lines that form those angles are perpendicular to each other. Perpendicular lines form right angles. I could write that here. However, I like to use that definition method, so I'm just going to say definition of perpendicular lines. Once I say that these two angles are right angles, then I'm able to say that they're congruent to each other. I first have to say that they are right angles, and then once I say they're right angles, I know that all right angles are 90 degrees. So I could write here all right angles are 90 degrees, but in keeping with my pattern here, I'm just going to say definition of right angles. And I'm essentially done. I know that triangle ABC and triangle EDC are congruent to each other, and the reason for that is angle, side, angle, postulate. Next proof, you can see that there's some given information, and there's a diagram. This diagram looks a lot different than the previous diagram, but there's one thing that you should be able to pick out right away. That's that these two triangles have that shared side. We'll talk about that in a moment. First, it says that BC and DC are congruent, so let's mark that on the diagram. Have to do. And then AC bisects angle BCD. Now it's telling us that AC bisects an angle, which means AC itself is not being cut in half. AC is the cutter. It bisects BCD. In other words, it takes this angle BCD and it splits it into two congruent parts. We know a bisected angle creates two congruent parts. So that means this angle here and this angle here are going to be congruent to each other. Now there's one piece of information that we're able to figure out without the givens. It does say that we're supposed to prove that these two triangles are congruent, prove that ABC and CDA are congruent, but we only have two different pieces of information so far. But there's one other thing that you know about this situation. You know that AC is that shared side, which means it's going to be congruent to itself. That is a property known as the reflexive property. Remember, we're able to use the reflexive property when two triangles share a side or when two triangles share an angle. All right, let's take a look at the statements and reasons for statement number 1, which is BC and DC are congruent, and then also for statement number 2, AC bisects angle BCD. It's fairly straightforward. These two are given. Next, for statement number 3, it says that angle BCA and angle DCA are congruent to each other. Well, we know that these two angles are congruent to each other because they are directly adjacent to each other and they are split by a bisector, right? That bisector creates two congruent parts. So we can say that the reason that these two angles are congruent is because the definition of bisector. You can be more specific and say definition of angle bisector. That's what I'm going to write here, but they will accept definition of bisector as well. Taking a look at statement number 4, which is AC is congruent to AC, you can see that AC is congruent to itself because of that property. The reason we mark it with that X is to remind us that it's called the reflexive property. It looks like we're all done with our statements here, except for that last statement, which is that ABC and CDA are congruent to each other. I know that these two angles, or rather these two triangles, are congruent to each other because this side, this angle, and this side are congruent to each other. In other words, if I go along the triangle in the correct pattern here, side, angle, side, right? The angle is included between the two sides, which means SAS postulate. All right, being fully completed with this proof, I can move on to the next one. In the next proof, it's a little bit more of a complicated diagram, so let's try to really understand which angles and which triangles it's talking about. It says in the givens that YLF is congruent to FRY, so let's mark that on our diagram. That's that piece of information there. YLF and FRY, they're located here. And it's important for you to understand how to name a set of angles, right? You name a set of angles with the vertex being in the middle. For example, YLF, L is in the middle, so L is the vertex. Same thing here, FRY, R is in the middle, so R is the vertex. Okay? And then RFY is congruent to LFY. You'll be able to see I marked those with 2 arcs because I already used that 1 arc here. So RFY is over here at the top, and LFY is over here at the bottom. So we have 2 different angles that are marked. That's the only pieces of information that they give to us. However, there's another piece of information that's hidden just below the surface here. And I know that these 2 triangles, FRY and FLY, are here, 2 triangles that are highlighted. And one other thing that I should be able to observe is that these 2 triangles share a side. And of course, you know what happens when we have a shared side. We can mark it as a reflexive property side. Now, before jumping into the statements and reasons, let's try to strategize what method or what postulate we're going to use. I have an angle here, and a side. So I could either use AAS or ASA. I'm looking at 2 angles and 1 side. Now, in order to figure out the difference between the two, we just look for whether the side is between the 2 angles or whether the side is not between the 2 angles, right? In this case, the side is between the 2 angles or included. In this case, the side is not between the 2 angles, or in other words, it's not included. In this case, I have an angle and an angle here. The included side would be RF, but I don't know RF. I know that the side that is given to us is FY, which is not included, which means I'm going to be using the AAS postulate. Now let's start filling out the statements and reasons. As usual, the first few statements are going to be givens because they're in the givens. Now, sometimes students like to put all the givens together, and sometimes teachers also like to do that. In this case, we split them up just so that you can easily see what's going on. We have our givens down. Next, FY is congruent to FY. We know that it is that symbol, that X symbol, which indicates reflexive property. Last but not least, triangle FRY is congruent to triangle FLY because of that AAS postulate that we named previously. We're done with our proof. Now, for the second section of this video, we're going to be talking about proofs that aren't pre-written for us. We're going to have to be looking at different types of diagrams, unfolding the diagrams, labeling them, and trying to draw the statements and reasons chart by ourselves. All right, here's the next one. It says that given that C is the midpoint of BD and also the midpoint of AE, so let's try to mark the diagram with that information right now. The statement is doing a little bit of a double duty here because it's telling me that C is the midpoint of both BD and AE. In other words, it's cutting BD as a line in half. So that means I'm going to be able to mark those with 1 hash mark each or 1 tick mark each. But it also cuts AE in half. It's also the midpoint of AE. So that means AC and CE are congruent to each other as well. So I'm marking those with 2 tick marks, 2 hash marks, right? So that one statement, that C is the midpoint of BD and AE, is doing double duty. And there's another piece of information that you should be able to readily see. these two angles here are opposites of each other. They share the same vertex, so we call those vertical angles. And now it's asking us to prove that ABC and EDC are congruent to each other as triangles. I can see that there's a side, an angle, and a side in that order, so I'm going to use the side angle side postulate for that. So before I even started writing out statements and reasons, I marked my diagram and I made my choice. I'm going to be using the side angle side postulate. I'm going to draw out a statements and reasons chart on the right hand side of the paper so that I can write down my statements and reasons. T chart. Now, what I'm going to do is write down the given first. It says that C is the midpoint of B, D, and AE, and the reason for that is going to be, of course, given. Next, what I'm going to do is pull out that piece of information that we got from the midpoint of B, D, and AE, which is that this side is congruent to this side, so BC is congruent to CD, and also that this side here, AC, is congruent to CE. I'm going to write them as two separate statements, but they're going to have the same reason. The same reason would be definition of midpoint, because I'm basing the fact that these two sides are congruent to each other on the fact that I know that C is the midpoint. I've identified these two sides are going to be congruent to each other, this side AC and this side CE, this side BC and this side CD. Now what I'm going to do is finish off with the last piece of information that I was able to determine. That's that these two angles are congruent to each other because of vertical angles. Word of caution, sometimes students like to say that angle C is congruent to angle C. However, in this case, you can't really tell which one is angle C, which specific angle C we're talking about. So in all cases, you should identify the angles by 3 letters, not just one. It's just the way to do it. And now we're basically done. We know that side angle side is going to be in effect. So that statement number 5 is going to be that ABC is congruent to EDC because we have all of our supporting pieces of information. We have the two sides and the angle between them. Another common student misconception, by the way, is that they don't have to write the numbers down. Of course, the numbers are important because you need to know that this number 1 statement goes to this number 1 reason. So please make sure you number your statements and reasons. That's something that sometimes we see with student work. All right, let's move on to the next proof. This question gives us some information that we don't typically see. It tells us that ADB as an angle and CDB as an angle are right angles. So what I can do for that is just mark that on the diagram. It tells us that angle A is congruent to angle C. Now I know that I just said that we always try not to name angles with just one letter. The reason I'm able to do that here, or the reason that they thought that it was okay to do it over here, is because angle A doesn't have any other stuff attached to it. Whereas in the previous problem, if I had just used angle C, that could have been this angle here, this angle here, this angle over here, or this angle over here. Since there's only one angle that's attached to angle A, or in other words, angle A only exists because there's one angle from this vertex, then they thought it was okay. Like I said, I think that is always important for you to name it with 3 letters, and I'm going to name it with 3 letters in my statements and reasons chart. But anyway, off my soapbox, let's mark up the diagram. Angle A is congruent to angle C. There's one other piece of information that I know from this diagram. It's that this side BD, is shared between these two triangles. So I'm going to mark it using that reflexive property that you know so well. Okay, again, I'm going to try to make a strategy here. I have to prove that these two triangles are congruent. So I know that I have an angle, and I have an angle, and I have a side in that order, right? Angle, angle, side. So it shouldn't be too tough to figure this out. This one's going to be angle, angle, side. This is a little warning here. I know that there are sometimes students that once they mark the diagram, they start writing the proof right away. They start writing the givens down. However, I like to identify the postulate first before I even start writing the proof. Here's why. You know that writing proofs is very similar to writing other argumentative essays or things that you might write in English and social studies, right? The reason that I say that they're similar is because you have to start from the information that you know, and then you have to make a point or argue a point or prove something using what you already know. In this case, it's the same idea. I have to write down the fact that these two triangles are congruent using what I already know, and figuring out which postulate to use beforehand is kind of like doing a pre-write, kind of like doing a graphic organizer or writing down notes in the margin or making an outline. The reason I write down the postulate before I even start writing the proof is because now I know where I'm going. Now I just need to write down how to get there. Of how to get there, let's draw our statements and reasons chart, and let's start filling in the given pieces of information. As I promised, I told you that I was going to write that instead of writing angle A is congruent to angle C, I wrote down BAD is congruent to angle BDC, or sorry, BCD. And the reason I did that was because it does say A and C here, but I always try to name an angle with 3 letters, BCD, BAD. All right, cool. So those are my two given statements. I already know that these two angles are going to be congruent to each other, angle BDC and angle BDA. The reason I am able to say that is because all right angles are congruent. An easier way to say it for me, I'm going to use definition of right angles. So I already know that these sets of angles are congruent. These sets of angles are congruent. So I have an angles and an angles. Now I need a sides. In other words, I'm going to say that this side BD is congruent to itself because of the reflexive property. Now all my pieces are in place. I have angles, angles, and sides. So I'm able to say that triangle ADB is congruent to angle CDB because of, that's right, AAS postulate. And I don't have to worry about what I'm supposed to be doing. I don't have to think about, oh, what am I supposed to figure out or whatever, because I already picked it before I even started writing the proof. It gives me a little peace of mind. There I go. AAS postulate proves that triangle ADB is congruent to angle or triangle CDB. Right along to the next proof. We have AB and CB are congruent to each other, and also that BD is a median of AC. Now, you need to remember the definitions that you've learned before, and median is one of the definitions you learned before. You need to know that a median connects a vertex of a triangle to the midpoint of the opposite side. So where it says BD is a median of AC, that indicates to me that D is going to be the midpoint of AC. In other words, this side and this side are going to be congruent to each other. I also know that AB is congruent to CB, so here's AB. I'm going to put 2 hash marks here, and I'm going to put 2 hash marks here. Now, if you made marks on your diagram before in other words, if you made these marks on the diagram before you made these marks on the diagram, it's okay that this has 1 hash mark and this has 2 hash marks. All I need to do is make sure that the hash marks match up with each other. This has 2, this has 2, this has 1, this has 1. I'm all good. Okay. Now, what I have is this pair of sides is congruent to this pair of sides, this pair of sides is congruent to this pair of sides, and I also see that these two triangles share a side BD, which means I'm using the reflexive property, which also means I can use the side postulate. Another thing that you could use, or one other piece of information that you could use to solve this problem, is realizing that if you mark this side and this side as congruent to each other, that makes triangle ABC an isosceles triangle. If it's an isosceles triangle, you also know that these two angles, these two base angles, are going to be congruent to each other. However, I'm not going to write the proof like that only because I'm trying to make it as straightforward as possible. I'm just telling you that there are multiple different ways of solving some proofs. In this case, I could use the side angle side postulate to prove it as well. But let me give you the side method because it's a little bit more straightforward. Let's get these two out of the way first. AB and CB are congruent, and also BD is a median of AC because those are both given. Now my third statement is going to be based on this median. I know that the definition of median is that it connects a vertex to the midpoint of the opposite side, so I'm going to be able to say that AD and DC are congruent to each other because of the definition of, I'm not going to use the definition of midpoint, I'm going to use the definition of median. Important to know that the only time that you can use definition of something is when that something is given to you or that something is something you have figured out or written down on the problem. Since it gives me median, I'm able to use the definition of median to say that AD and DC are congruent to each other. The statement is going to be based on BD being congruent to itself. That's the reflexive property. Nothing else needs to be said about that. And we can say that triangle ABD is congruent to triangle CBD because of the side postulate. I want you to know that this diagram is very similar to the previous diagram that we just looked at. As a matter of fact, they're exactly the same diagram. However, the thing that makes the difference is the pieces of information that are given to you. Here, I'm given information about right angles and the base angles. Here, I'm given information about the sides and the fact that BD is a median. Either way, what you're going to do is take the given information, regardless of the diagram, take the given information, put it on the diagram, and then use that information to determine which postulate to use. All right, moving on to the last proof. This is a coordinate style proof, which runs a little bit different than the other types of proofs. We don't have to write a statements and reasons diagram, but our first step is going to be to graph points. So let's do that now. Coordinates D, A, and N, which spell out Dan, great name. That is going to be graphed on these coordinate axes to the right. Graphed my points and I've connected the dots, but of course one thing that you need to include also is labels for the points, because otherwise we're not going to know which two lines we're going to be finding slopes or distances for. In the problem, it says that we're supposed to prove that triangle DAN is a right triangle. We know that right triangles have a right angle within them, and we also know that if the triangle has a right angle within it, that means that two of its sides meet at that right angle, which means that two of its sides must be perpendicular. Since those sides are perpendicular, they have to have the quality that they have negative reciprocal slopes. That's a long way of saying what I'm going to do in order to prove that this triangle is a right triangle is try to figure out what two lines have negative reciprocal slopes. And the reason we draw the diagram first is because now we're able to see which sides are going to have negative reciprocal slopes. In other words, which two sides are going to meet at a right angle. And it looks to me like angle DNA is not going to be a right angle. Angle NDA is not going to be a right angle, but this one sort of looks like a right angle. We're thinking that this one is going to be a right angle, so we're going to find two slopes. We're going to find the slope of NA, and we're also going to find the slope of A. So on the side here, we're going to find two slopes, and hopefully they're going to be negative reciprocals. Hopefully that's going to show that these two lines are perpendicular, which means they form right angles, which means that it is a right triangle. So let's try it out. First, let's find the slope of DA. It's a good idea to write down the formula first. The slope is equal to y2 minus y1 over x2 minus x1. And now let's substitute in the values from D and A respectively. By labeling x1 and y1 and x2, y2, I can keep myself organized here. I substituted y2 minus y1, which is 1 minus 4, and x2 minus x1, which is negative 4 minus negative 10. Simplify this using the calculator. Get negative 3/6, or in other words, negative 1/2. I know I can convert this into negative 0.5. I know the calculator does it automatically like that, but I'm going to leave it as a fraction because eventually what I want to do is show that this fraction is the negative reciprocal of the other fraction that I'm going to find for the slope of the slope of AN. So speaking of the slope of AN, let's find that now. And I'm going to write down the slope formula first, which is y2 minus y1 over x2 minus x1. And now I'm going to have to change my labeling here because my x1, y1, and my x2, y2 are going to be different. Now I relabeled A and N as my x1, y1, and x2, y2 respectively. 5 minus 1 on the top, negative 2 minus negative 4 on the bottom. Simplify that using your calculator and you get this. You get 4 over 2, which simplifies to 2 over 1. Now I want you to take a look at these two slopes. We have negative 1 over 2 and we have positive 2 over 1. You should notice that they are reciprocals of each other, which means they're flipped upside down, and one of them is negative and one of them is positive. So these are so-called negative reciprocal slopes. I'm going to write that down. DA and AN have negative reciprocal slopes. Another piece of information that I know is that when two lines have negative reciprocal slopes, they are perpendicular to each other. Easily just write down DA is perpendicular to AN. Once I know that angle DAN is going to be a right angle. Once I know that angle DAN is a right angle, I'm going to draw that in here. Once I know that angle DAN is a right angle, then triangle DAN must be a right triangle because all right triangles have one right angle. Like that, I'm done. How do I know I'm done? It says that prove that triangle DAN is a right triangle, and I've just done that. All right, this was the video on the Unit 6 review for proofs. Good luck studying.